Okay, good afternoon everyone. So today we'll be looking at Singleton Design Pattern. It's a very simple design pattern and it has few caveats to it, but hopefully it will be covered short in a short video. So first of all, let's look at the definition of singleton. So it ensures a class only has one instance and provide a global point of access to it. Okay, so like the definition is pretty self-explanatory. We need to ensure that only one instance of a particular object exists throughout across like one instance across application across threads across everything. So there will only be a single instance for that object, right? So why don't we mark the instance as static, right? We can in if I in terms of Java I can simply say that let's mark the, like let's say I create an int, I mark it as static, right? Okay, so this has few problems. First of all, static variables are initialized whenever the application compiles. So if our object is very heavy, then it will be initialized when the application at the compile time, which will again increase the compilation time. Okay, so that's why this approach does not work. Obviously, if you have a very simple application, marking object static can like alleviate some of your issues, but still uh, like it can be changed. Like if you use a class loader, or let's say if you access it across threads, uh, like you can mess it up. So our purpose was failing, so one instance was not maintained. Okay, and second part is provide a global point of access to it. So for example, I know that I have created the instance, but I if someone wants access to it, then it should be able to provide it, right? Let's take up the example directly. It's a simple example. Okay, so let's okay, I already have singleton. So what I will do, I will declare the constructor private. What happened here, right? So the class is public but the constructor is private, so no one would be able to instantiate this. So how will one access it, right? So for accessing it, I am creating a public method, public static get instance. Okay, and what will this instance return? It will return itself. Okay, and where will we store itself? So we can just say simple singleton instance, and whenever we have this simple singleton, if instance ins if instance equal to null, then instance is equal to new simple singleton. So obviously and return the instance. Okay, so here we have created a single instance, and only this object, like this class itself, would be able to instantiate it. No other class can instantiate it, right? So okay, just give me a moment. Hmm. Okay, Just checking why this warning is coming. Instantiation of utility class Singleton. Weird. I don't know. It's an instantiation of utility class simple Singleton. Contract pure equal to true. Okay. I believe it's not a very critical warning. Anyways, so just I will log it system dot out dot println I am, yeah, simple singleton being created. Okay, so if let's say my main method wants this singleton, it will just say simple singleton dot get instance, and from anywhere, like all the classes will only be able to get it like this only. So we ensure that it only a single object exists of this, right? So let's run it. Right, simple singleton being created, and after creation, if I do it again, let's say oh my god, simple singleton dot get instance. So second time it won't be getting called simple singleton. So it's only called one time. And if I say this provide simple singleton being provided, right? So if I just go here, so first of all it's being created, then it's provided, and next onwards after being created it will only be provided. Okay, that's a very simple singleton, like literally a simple singleton concept. But there are few caveats. There are few caveats. What happens, right? What happens? Let's just do a practical thread equal to new thread, new runnable. Okay, it's my thread 1. Okay, and then let's create thread 2. Okay, so what happens if my singleton, let's say if I dot get instance, and this thread also gets the instance, right? And let's say thread 1 dot wait a second. Oh yeah, start. 1 second. Thread 1 dot start, thread 2 dot start. Let's create one more thread. Okay, thread 3 dot start. Let's run this once. Okay, so what happens? Each of our thread created the singleton, right? And then dot sleep. Let's say 500 milliseconds or 1 second. Yeah, interrupted exception. I know. Let's create our thread 4 and thread 4 dot start. Yeah. Okay. Yeah. So see, when these threads are running, right? So first the simple singleton is being created, then being provided to each of the thread. After some time, once the initialization has, like, once it has been, like, these three threads does not know that the object has been initialized, right? So like here our principle is breaking. What's breaking? Basically we have multiple instance of the same object. We wanted that we only get a single instance. How can we fix this? Okay, so one way to fix this is basically we create the instance here only, equal to new simple singleton. Okay, so and we know that the instance is already created, so we can provide that directly. So if I go here and I run it now, so it's being created once, then it's being provided. Okay, but this is a problem. Like it might be satisfying maybe 80 to 85% of the use cases, but usually what we keep singleton is a heavy object. For example, you will create it HTTP client, maybe a DB connection. All these heavy objects are usually singleton. Like we can keep them, not usually, we can keep them as singleton, right? So doing this, what happens is we are losing the lazy initialization, right? We are directly eagerly initializing it. So at the like application start, our application will immediately face a load, right? Although or and it might happen the simple singleton may no one may use that, right? Rare scenario, but no one may use that. And like even if no one has used that, it's still being created, right? So let's see how we can resolve this problem. Okay, next we can resolve this basically by marking this as synchronized. By marking this as synchronized. How we mark it as synchronized? Like this. Right, synchronized, public synchronized. Can we place synchronized anywhere? Okay, anyways. So yeah, second way we can solve is we can mark it as synchronized. So what synchronized basically does is it basically locks this method until the thread releases it. So for example, until this thread 1 has released that method, thread 2 won't be allowed to access it, right? So let's just run. Okay, so same result, created once, then provided 3-4 times. Okay, but this is again has a problem. Like for example, you have a server which is being hit by millions of requests, right? Then this might slow down your system by a factor of 100. Why am I saying that? Because uh, because if this method is locked till one thread is accessing it, the other thread the other thread will not be able to access it. Also, a condition of deadlock may arise. Like our initialization is simple, other initialization may be complex, so it might happen that this might go in some loop or something. So one thread will be blocking this and the other thread will not be able to access it. So this is not a very safe way to do it. Also, the performance implication is very high because second. Yeah, performance implication is very high because again multiple threads are blocked and will not be able to access it till the time one of the thread is accessing it. Okay, so what should we do now, right? So there's a very popular concept of double check locking. So basically double check locking, what it does is we first check to see if an instance is created, and if not, then we synchronize. Like then this way we only synchronize the first time through, like we only synchronize it only first time, right? For first creation, after it is created, the synchronized is basically redundant here, right? So what we will do, we will mark it as volatile. Static volatile, my bad, volatile. So what does volatile do? Volatile, okay, let me just a brief sidetrack. So like each of the thread, they have some memory. So when they gets any instance, they store it in a local memory and they work over it. What volatile ensures that they always access from the main memory. So any changes to the instance are immediately visible to all the threads. Okay, just a brief summary. You can read on volatile in your separate time, or I may make a video about it in some other time. Okay, now what will happen? We need to mark it synchronized. Like if it's null, then only at the time of creation. So synchronized, let's take a object. So this object is basically our lock, right? And we will instantiate it here. Like again inside the synchronized, you can check that if like check again if it's still null. If instance is still null because maybe any other has initialized it, so then instance is equal to new singleton, simple singleton, right? Yeah, that makes sense. Okay, that makes sense. Let's check it. Oh, why is it created two times? I marked it volatile, synchronized it here. Interesting. One second. I think I'm missing something. So if I keep the log as an object, okay, let's read on. So if I keep it as an object, then it is being created each time, right? But if I create this as a class, okay, I am going to read on what's this is doing. Let's read together, right? So let me just quickly come here. Okay, so synchro keyword Java. What does log do? Was it not working? Strange. Anyways, so intrinsic logs and synchronize. Synchronous built around the internal entity known as intrinsic log or monitor log. The API solution often refers to this entity simply as a monitor. Intrinsic logs play a role in both. Every object has a Every object has an intrinsic log by convention. A thread that needs exclusive and consistent access to an object will has to acquire the object's intrinsic log and then release the intrinsic log when it's done with them. A thread is said to have own intrinsic log between the time it has acquired the log and release the log. As long as thread owns a intrinsic log, no other thread can. Okay, I got it now. Why it's not working? Let me just quickly. Yeah, I got it. Actually, every time we were creating a new log, right? We were creating a new object here. That's why each time no locking was happening. So what we can do, we can either directly take this class because this is our singleton. But what I prefer, I will say I will have a lock object, which can be an object, right? Acha, right? And then I provide this to this. Okay, so this way our it's a double locking, double checked lock. Okay, so now let's try it. Okay, it's created, so it's fixed, right? You understood the problem, right? Because each time we were creating a new lock, it was never getting acquired. So we basically standardize this. Yeah, lock may be final, yeah, it sure can. No problem. Session. Okay. Now I am going to give you a very easy and surpriseful method, which I also recently got to learn. Instead of doing all this, like we can basically what we can do, there is a technique called, what do we call it? Okay, how one more thing I forgot to discuss. This is still not a good solution. Like 90% of the books and articles say this is where they end, but this is not a good solution. Okay, so because let me give you an example specific to Java. Okay, I don't know about other languages, but in Java there exists a concept called reflection. Okay, so basically what reflect, if I can get to the doc, reflect produces. Yeah. Yeah. So using reflection, what we can do is, okay, the docs are not that good, but let's using reflection, what we can do is we can manipulate the classes at compile at runtime. Like I can, I'm not very proficient in reflection, but I can basically get an instance of this and modify it at runtime. Number one. Number two, there's also a concept of class loader. Okay, so the class must be other. So let's take a look what is class loader. A class loader is an object that is responsible for loading classes. The class loader is an abstract class. Given the binary name of a class loader should attempt to locate or generate data that constitutes a definition for a class. A typical strategy is to transform the name into a file name and then read a class file of that name from a file system. Yeah. So in brief, I can basically create a new class loader. Not like this, but yeah, I can pass it my class name. Just a brief example, it might not be very accurate, just giving an idea. So I can pass a class name and I can create another class loader like this, right? So not sure how to exactly create it, but yeah, you can create two class loaders and again we will have two objects, right? So this still does not solve our problem, right? So what's the ultimate solution? So the best solution which I have seen is basically make this as an enum. Just bear with me. Enum. Okay, make this as an enum, and then we won't be needing anything. We can just say simple singleton, right? And what we can do, okay, let me one just, so we have to create, keep this simple singleton, right? Yeah. Mm, just one, give me a moment. This was, I think it was how it is. So why we are creating an enum? Let's first understand that. I will look, then I will look into code why it's not working. So basically, any enum is synchronized by default. Number one, that solves the problem. Second, it is not impacted by reflection, and third, it is not impacted by class loader. So it is the best solution to define a singleton. Let me just see. Okay, I think I'm missing a concept. Let's search the net for it. Enum singleton. Instance, okay. Okay, let's read through what's here. Making a class and singleton can make it equal to test 9. So, and why you should enforce the private constructor on enum type as impossible to substitute a mock implementation with a so every count approaches implement by simply make an event type and so approach. Okay. Uh, hmm. Hmm. Yes, I need to provide a method to it. But why is it not taking it? Return something. Private string something. Do I even need all this? Hmm. Okay, yeah, this is how it is created. Okay, makes sense. We don't need any of this. Yeah, so this is the best way to initialize a best way to initialize a singleton. And this video took around 26 minutes, which is a very, oh, sorry, I never, 1 second. Yeah, sorry, my screen was not visible. So, yeah, I'm saying that there was some redundancy. I removed that, and this is like the best way to initialize a singleton. So we create an enum, we create a private constructor of it, we create a method in it, and in the main we can just keep the code same, and it's across thread. It's very working very beautifully. And even if I call again, let's say simple singleton dot simpleton dot dot get instance, then also it's working. Right, it's working perfectly fine. Should not be accessed by that. 1 second. Yeah, this is the right way to access it. Yeah, so yeah, this is the best way to implement a singleton as far as Java is concerned. Otherwise, obviously, there is double locking and other methods as well. Okay, that's all for today.